Okay, so we talked about last week that triangles are congruent if all three sides of corresponding sides are congruent, as well as all six angles, all three pairs of corresponding angles are congruent. That means six facts are true. That's a lot. Fortunately, we don't have to do that to prove triangles are congruent. There's actually five distinct ways. The first of which is the side postulate. So the side postulate, which you would write SSS, is if three sides of one triangle are congruent to the three sides of another triangle, then those two triangles have to be congruent. I don't need to know anything about the angles. I just need to know three sides of one are equal to three sides of the other. So if we look at these examples, what additional information would I need to show that these two triangles are congruent? So I know that GJ is congruent to HJ. That's what that little mark means, remember. And since JK is itself, remember we learned a property called the reflexive. So we know that JK is congruent to JK by reflexive. So what else would I need to know? Well, what I would need to know is I would need to know that GK is congruent to HK. And then I could prove these triangles are congruent by side. Now, what is a congruent statement? The congruent statement is when we say the triangles are congruent, and it's important that the vertices go in order. So when we look at this, G matches up with H. So I'm going to say triangle G is congruent to triangle H, and then J is the same spot. So GJ, HJ, and then K goes together. So my congruent statement is triangle GJK is congruent to triangle HJK. Now the order doesn't really matter as long as they match up. So I could have also set that as triangle JGK is congruent to triangle JHK. So notice that my letters that were in the same spot are still in the same spot. So I want you to pause and try to figure out what I need to know in the second set and what our congruent statement is. Okay, so what I would need to know here is I would need to know that AB is congruent to XZ. And then our congruent statement would be that triangle ABC is congruent. So A is next to the single one. So I would need to know X. And then B is the double one in between the double and the X. So that would go with Z. And then Y goes with C because Y is in between the double and single. Remember, the reflexive property says that JL is congruent to JL because the line segment, and we can use it for an angle too, or angle is equal to itself. And that's going to be important when we're proving triangles are congruent. So determine whether you can use the SSS postulate to prove these triangles congruent. If so, write the statement. So number one, the answer is no, because I don't know that EG is congruent to HK. Number two is yes. And now I want you to pause and think about the congruent statement to 2 and whether or not you can do it for 3. So, yes, I can for number 2. And I'm going to start with TUS. And it really doesn't matter as long as you do corresponding. Is congruent. So T is in between the 1 and 2 mark. So T goes with X. S is in between the 2 and 3 marks. So S goes with B. And U and W. Number 3, the answer is yes, because I know PR is congruent to itself. So that would be triangle PNR is congruent to, P goes with P, Q is in between the 1 and 2, 1 and 2, R. So now number 4, we want to show that triangle JKL and triangle NPQ determine if these are congruent or not. If so, explain. And we're on a coordinate paper. So the only way on coordinate paper I can show if things are the same is if I do the distance formula. So remember, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm going to do that I need to do it for JK, KL, JL. I also need to do it for NP, PQ, and NQ. So I'm going to do JK, and then I want you to pause and do the rest. I'm going to remind you how you can use your calculator. So for JK, it's 2 minus 5 squared, JK is 2 minus 1 squared plus 5 minus 1 squared. So on my calculator, it is going to show me, that I want to do second square root, parenthesis, 2 minus 1, parenthesis squared, plus parenthesis 5 minus 1, parenthesis squared. And that gives me 4.123105626. So I want you to pause, and I want you to find the lengths of the rest, and then come back and check against mine. Okay, so looking at all my distance formulas, I see a couple of really important things here. I see that KL, JL, NP, and NQ are all the same length, which means those are all congruent, which means both these triangles are isosceles. So then what's really important is I need to check the other side. So when I look at the other side, I see that, I said KL or JL. I did not mean that. I meant JK. Sorry, JK is congruent to KL, is congruent to NP, is congruent to NQ. And then JL is equal to PQ. So that means these triangles are congruent. And I can actually say they're congruent two different ways. I can say that triangle JLK is congruent to triangle PQN. I could also flip the J and K and say that triangle K, or no, I can't flip. So these two triangles are congruent. So now let's try a proof. So I am given that GH is congruent to JK and HL is congruent to JL. And then I know that L is the midpoint. L is the midpoint of GK means that GL is congruent to KL. And that is definition of midpoint. And therefore, these two triangles are congruent by side, side, side. So now we're going to try another proof. Two more proofs together. So I want you to pause and I want you to think about this one for a little bit and then come back. Okay, so hopefully you paused and thought about this some. So we're given that JM is congruent to NK. And then we know L is the midpoint of JN. So if L is the midpoint of JN, that means JL is congruent to LN. And that's definition of midpoint. The midpoint breaks it into two congruent parts. Then I also know that L is the midpoint of KM. So that means LM and LK are equal. Because again, definition of midpoint. Now if I look, my triangles are the same, and this should say triangle MLJ and triangle KNL. So that means triangle MLJ is congruent to triangle KNL by side, side, side. So again, I want you to pause and I want you to try 21 and then come back and see if you can do it. Okay, so now let's take a look. So we have our statement and our reasons. My first statement is that two sides are equal. So that means MJ is congruent to ML. That's the given. And that's already labeled. Then my next given is K is the midpoint of JL. So we've talked about midpoint already a couple times today. So if K is the midpoint, that means JK is congruent to KJ. Or I'm sorry, LK. I said JK. LK is congruent to KJ or JK. Doesn't matter. And that's definition of midpoint. Now I have two sides. How can I get that third side? Well, if I look, the triangles I want to prove congruent are MJK, which I'm making yellow. And then I also want to prove that's congruent to MLK. And I flip-flop these, but I made one green and one yellow. So notice that they overlap right here at MK. So that means I want to use my reflexive property. So I'm going to say MK is congruent to MK. And that's reflexive. And then I know my triangle MJK is congruent to triangle MLK by side, side, side. So that's it for our video today. If you have any questions, please bring them to class.